Hello everyone. Today we discuss the asymmetric Aldol reaction. The Aldol reaction is a distereoselective reaction. That means when base abstract the proton, there is formation of enolate ion. That means if we get the cis enolate, we get the syn aldol, and if we get the trans enolate, we get the anti aldol. Now, in today's lecture, we discuss the remaining part of asymmetric Aldol reaction. The stereoselective enolization is needed for stereoselective aldols. The cyclic transition state explain how the enolate geometry controls the stereochemical outcome of the aldol reaction. But what controls the geometry of the enolate? For lithium enolate of ketone, the most important factor is the size of the group that is not enolized. That means the large group forced to enolate to adopt the cis geometry, while the small groups allows the trans enolate to form. This is the most important parameter to control the geometry of the enolate. That means for lithium enolate of ketone, the most important factor is that the size of the group. Okay, that means large group force the enolate to adopt the cis geometry, while the small groups allow the trans enolate to form. Because we can't separate the lithium enolates, we just have to accept that the reaction of ketones with small r will be less distereoselective. Okay, now here this is a ketone, and here when we treatment with the LDA we get the enolate. Here the R, that means tertiary butyl groups. Here the different proportions, that means this having the cis geometry. Here this is 1 2 1 2, that means this is the cis and this is trans. Here this is 98% and this is 2%. Here R is equal to, that means here ethyl it is 30% and here it is 70%. That means here we see that from this reaction we conclude that the large group, this is tertiary butyl groups. Here if we consider R is equal to tertiary butyl groups, it occupy the cis geometry. We get the cis geometry, that means from the cis enolate we get the syn aldol. And here the small groups, it occupy the trans geometry. That's why here this is 70%, we get the trans geometry, and or the trans enolate. From this trans enolate we get the anti aldol. And with boron enolates we don't have to really on the structure of the substrate, or we choose the groups on boron, and we can get either cis or trans depending on which group these are. The boron enolates are made by the treating the ketone with an imine base, often triethylamine or isopropylamine, and the boron halide where X is a good leaving group such as chloride or triplet, that means CF3SO3 minus with bulky groups on boron. At that time the two cyclohexyl groups, such as the two cyclohexyl groups, it occupy the trans enolate, or the two cyclohexyl groups, the trans enolate form. Here the formations of the trans enolate from the most of this ketone. Here this is ketone, and here the boron reagent when we use in presence of triethylamine we get the trans enolate. Okay, now then on treatment with the aldehyde, here trans enolate, of course we get the anti aldol. The boron enolate, that means this one, the boron enolate reacts readily with the aldehyde to give the anti aldol produced through the same 6-member transition state that you have see for the lithium enolate. Okay, that means here this ketone, and when we use the boron reagent we get the preferentially it form the trans enolate, and this trans enolate is react with the aldehyde, we get the anti aldol. And with smaller boron substituent, the cis enolate form the selectively. Here The boron is a part of the bicyclic structure known as the 9-BBN. 9-BBN, that means the 9-boria bicyclononane. The cyclic part may look large, but uh, as far as the rest of the molecule is concerned, it is tied back behind the boron, and the methyl group can easily lie the cis to the oxygen. That means in this way here, cis to the oxygen and the cis enolate. Then this, from this cis enolate we get the syn aldol product. The dibutyl boron triplet also gives the cis enolate. Here this one here ketone, and ketone on treatment with this boron reagent. That means this is a di-n-butyl boron triplet. Here we get the cis enolate. That means from the cis enolate, this cis enolate on treatment with the aldehyde, we get the syn aldol. That means there is formations of the syn aldol. Okay. So friend, never miss a video. Subscribe to my YouTube channel. Okay, thank you.